the previous lesson, we learned what square roots and exponents are and how to write them. In this lesson, we're going to be going over estimating square roots. Perfect square numbers are products of an integer multiplied by itself. Some examples are in this box below. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are perfect square numbers, since when they're square rooted, an integer is resulted. So 1 squared is equal to 1, 1 is an integer, 2 squared is equal to 4, 2 is the integer, and 3 squared is equal to 9, 3 is the integer, all the way up to 10 squared equals 100. So it's highly recommended that for this lesson, estimating square roots, these 10 numbers shall be memorized. So let's start with our first method of estimating square roots, the number line method. And suppose you have to find the value of the square root of something like 22. You know that this is not a perfect square number since it doesn't fit anywhere between here. So how will you find the value? By estimating, and without using a calculator. So the first thing I want to do is see where the square root of 22 lies. So it lies between 16 and 25. So I have my number line ready. I'm going to write the square root of 16 here and the square root of 25 here. And I'm going to write their integer values above. And somewhere around the middle, let's say here, I'm going to write 4.5, halfway through 4 and 5. Now you should be able to point out that the square root of 22 is just 3 steps from the square root of 25 and 6 steps away from square root of 16. So of course it's much closer to 25. I can't plot the steps on the number line since we're estimating, meaning that there's no correct formula. Since it's closer to 25, it will be somewhere between 4.5 and 5. So it's approximately 3 steps away. So considering 16 and 25, the distance between 16 and 25, which is 9 steps, 3 steps away will be, I'm estimating, about 1/3 of the way there. And I'm going to plot my point. And I can say 4.7, not 4.6, since that will be too close to the halfway point, and it's a little bit more than half closer to 25. So I will say about 4.7 maybe. And it's okay to make mistakes sometimes, but I'm going to check my answer. .69, so yeah, approximately 4.7. So I also used the method of elimination to determine my answer, such as, oh no, it can't be 4.6 since it's much more closer to 25. But it can't be 4.9 either since it's not that close to 25. So our next example is the square root of 123. So this box won't be of much help now since it's bigger than 100. So let's see if it's bigger than 11 squared. Yes, it is, but only by a little. So you know that it's probably between 11 and 12 squared. So I'm going to write the square root of 121. And over here I'm going to write the square root of 144, which is 12 squared, and their integer values above. Okay. And make a halfway point somewhere over here again. So you know that 123 is just 2 steps away from the square root of 121, and approximately 21 steps away from square root of 144. So it's much more closer here. I'm just going to make a mental note that the difference from the square root of 121 and the square root of 144 is 23 steps. So 123, it's 2 steps and there's a gap of 23 steps. I'm not going to do any algebraic calculations since we're estimating. So it's probably somewhere over here, much more closer. Maybe over here. I'm estimating. Plot my point. Maybe 11.1. Okay, so I said 11.1. It can be 11.4 since that would be way too much. Same with 11.2 and 11.3. Maybe 11.0 as well. But let me just check. And 11.09. Perfect. Almost perfect. So that's the method of the number line. Second method is the squared sketch method. I probably named that. I'm not even sure if that's its right name. Okay, so I have the square root of 46, and again I'm going to check where it lies. Yeah, between 36 and 49. So I'm going to put the square root of 36 in here, and the square root of 49 in here. I'm going to write their integer values respectively here, 6 and 7. And now I'm going to determine where 46 lies. So again, I'm going to make a mental note that 46 is just 3 steps away from 49, but 10 steps away from 36. So much closer to 49. Here's my halfway point, 6.5. So it's probably somewhere over here, between 6.5 and 7. Even more closer to 7, I think. So maybe it may be 6.7, but I think that may be a little too far away from 7. So maybe 6.8, I'm guessing. 6.6 will be way too less. So I'm going to make my square here and bring it down here. And I'm going to write the square root of 46 and 6.8 over here. Now for checking, 6.78. Okay. And for your information, no, I'm not checking beforehand. I'm actually estimating with you guys. So the answer to this is 6.8 approx. Now I have a word problem here. I'm giving it to you to solve. So Archimedes is buying wallpaper to cover the entire square-shaped wall in his living room, which is 18 square meters. He finds some wallpaper square-shaped with dimensions 4.2 meters. Using the number line or the squared sketch method, determine if this is sufficient. Okay. I'm going to be posting my answers in the comments below sometime around next week from now. And that's it. Thanks for watching, guys. I hope you found this video helpful. Please be sure to subscribe if this video helped you. I will really appreciate it. My next lesson will be solving equations and word problems with square roots and exponents. And if you have any questions about this lesson, you can always find me in the comments below. And if you want more information on myself, Archimedes Tutor, or the lessons I will be uploading, please visit my website www.archimedestutor.com. Until then, stay tuned to Archimedes Tutor.